Geometry Chapter 10 Lesson 1, we've looked at the area of parallelograms, and now we want to look at the area of triangles. And we're going to move rather rapidly through these next couple of lessons because really the concept of area that we've talked about already, talking about the units, talking about the formulas, talking about substituting in, recognizing the variables, recognizing what those are in the diagram, and then substituting in is all the same moving forward. The only new part is knowing the formula. So you're just going to need to memorize the formula, and then simply follow the same procedure. Substitute in the values that you're given so that you can determine the value that you're missing. If you're missing a particular value and the value that you need in order to complete your equation is not in the diagram, then there's going to have to be another way that you can determine that, so you may need a couple steps to do the problems. The area of a triangle is simply 1/2 the base times the height. Again, the same properties apply. The base and the height that you use must be perpendicular numbers, and you simply take 1/2 of those. Again, any side can be a base. As long as you have a height that's perpendicular to that base, you have the values that you need. And really, if you look at this, it looks to be very similar to the parallelogram. It's just the base times the height and then taking 1/2 of that. And that's because if you take any triangle and you put a center point on one side and you rotate it around, it always forms a parallelogram. So a parallelogram is base times height. The triangle is 1/2 of a parallelogram. So every parallelogram is 2 triangles put together, or every triangle is 1/2 a parallelogram. That's depending on how you look at it. So again, that's the formula, that's the lesson. I'll do a couple of examples for you so that you can see how it works. As I look at number 9 here, it is a triangle that I'm trying to determine the area of, so I choose the formula 1/2 base times height. As I look at the diagram, I'm looking for a base and height, so I'm looking for 2 values that are perpendicular to each other. Now, this is a trick, this one here. The shaded blue area is what I'm trying to define, or trying to find the area of. That's the triangle. This 2 feet that they mark outside on this has absolutely no bearing on the base of the triangle. It is not the base of the triangle that you're trying to determine is not this part and this part together, because remember we talked about this triangle that's created by these dashed lines isn't part of the figure. It's simply created because I need to identify perpendicular lines, and in order to do that I have to extend these sides out. So don't be tricked into using numbers that aren't there or that shouldn't be used. Just because a number's in the problem doesn't mean you have to use it. Know what it is you're looking for, and when you're going to the diagram, just simply use those values. So the number 3 is perpendicular to this number 2, so those will be my values. So the area is 1/2 the base, which is 2 feet, times the height, which is 3 feet, and then I simply multiply. The half can be multiplied by either number first. Always use an even number because then it reduces. So 1/2 of 2 is 1, and then 1 times 3 is 3, and then feet times feet is feet squared. So the area of this triangle is 3 feet squared. And if we go up here and look, we have the correct answer. Okay, so be careful about those dashed lines. Those are not part of the figure that you're trying to calculate. They're simply extensions allowing us to find the base and the height that we need. When you're working with word problems in this lesson, just like always, remember if a diagram is not given, go ahead and sketch one, and then what you want to do is try to divide that figure then into parallelograms and triangles, because we know how to figure out the area of a parallelogram. We know how to figure out the area of a triangle. If a figure is just a combination of those 2 things, I can find the area of each one separately and then add all of the areas of each section together to get the area of the total region. An example would be something like this. You'll notice that the ends of these flower beds are triangular shapes, so you would use the triangle formula to figure out those 2. The values or the shapes in between these are parallelograms, these parking stalls. These are just parallelograms, so I would use the area of a parallelogram to determine one, and then I have 4 of them, so I just add 4 of the same areas together, and then the 2 triangle areas together, and that would give me the area of this entire parking area on the right. Now, I don't know if that's what this question is asking for. I'm just using that as an example. Take the entire figure, divide it into triangles and parallelograms, find the area of each one separately, and then add those together. That will give you the total area. And that's going to be a concept that you're going to want to use later on when we talk about surface area. So very quickly here, if I was doing number 32, I would plot the point D at 0, 0. I would plot the point E at 2, 4. I would plot the point F at 6, 4. It's 2, 3, 4, 5, 6, 4. And then I would plot the point at 6, 0. 1, 2, 3, 4, 5, 6. And as I draw this, I have this figure that looks like this. Now, this is a combination of a parallelogram and a triangle. If I draw this here, then I can find the area of this by finding the base and then a height. This happens to be a rectangle, so the sides are actually perpendicular. And then the triangle, I would take the base from here to here, and the height would be this side. Find the area of each of those, add those together, and that would be the value or the area of the shape. So again, not too difficult. You need to memorize the formulas, know what you're looking for in the diagram. Bases and heights have to be perpendicular numbers, then substitute those values in, calculate the value that you need.